Well, I mean, a couple reasons. The two big reasons are to activate students' attention, and the other is to catalyze their cognitive processing. So you get them to take notice and think. Whereas in so many cases, people regret coming to class and they anticipate leaving, where what we want them to do is anticipate coming to a science classroom and regret leaving. And so discrepant events can be used in many places in an instructional cycle to activate interest and catalyze cognitive processing. My students, when I was a classroom teacher, absolutely loved them. And on the other hand, they hated them because they wanted to know the answers right away. And good inquiry-oriented teaching doesn't give students the answers. It helps them construct it on their own, especially if it was a Friday and they didn't have the answer by the end of the class. They did a whole lot of thinking going out the door and over the weekend. But it was very motivational for kids. And in fact, a side effect was that classroom management issues were much less a problem. The other context where I use them now as a science teacher educator is in professional development with teachers. And learners of any age love discrepant events. And it challenges their thinking and engages them in a fun way that lecturing per se typically doesn't. So a science discrepant event shares some similarities with a magician's trick in that one of the purposes is to engage the students' attention, to activate their attention, to get them thinking. The difference is that a magician actually doesn't want you to figure out the trick, and that oftentimes it's a trick in the sense that something is rigged. Nature has all kinds of anomalies or counterintuitive discrepant events that there is no trick other than figuring out what's the underlying pattern that predicts it. So in this case here, I have a simple two balloons connected through a spool, and it raises the question, when I release the twist here and let the air mix, what might happen? And so what commonly people think of this is that the large balloon is more powerful and stronger, and that it'll blow up the small balloon, and that they'll be reached the same final volume. So let's do that and see what occurs. So in fact, that was a discrepant event, counterintuitive. Very few people predict that the small balloon will blow up the large balloon and wind up with the reduced volume itself. And in fact, that is what happens. And so then the challenge for a scientist or a science teacher working with science students is to help scaffold their instruction so that they can understand what's the underlying pattern here that explains this discrepant event. So part of teaching is, again, to activate their attention, but then to catalyze their thinking, their cognitive processing, so that they can explain and understand something and use that to make predictions, more accurate predictions of other phenomena, unlike a magician. Well, fortunately in science, the issue isn't the lack of activities. As a former chemist, back to the days of alchemists, we had many demonstrations and magician's tricks that were discrepant events. So I don't so much claim to have originated any particular discrepant events. Some of the variations that I take on them, the inquiry questions that I put in the book, and having scientifically accurate answers is sort of the unique thing. And then the most unique thing about the books is this second purpose for the discrepant events. Yes, they're great activities to use to teach science to kids, but they're great activities for teachers to learn about how to teach and how to reframe some of the good activities they may have to make them more oriented towards inquiry and constructivist kinds of thinking. So it's not so much original demonstrations. And most people that think they've done something original just haven't looked far enough back in the history of science for activity. So in science, the problem isn't a shortage of good activities, although many great activities are not very commonly known. Well, the sad reality is that oftentimes the younger children are more curious and willing to take risks to make what I call mistakes, M-I-S-S-takes. That's the way science grows. And oftentimes the longer kids stay in school, and regrettably many teachers, worry about having the right answer. And so they it's a little more risky for them to offer answers. And that's why the way you ask questions, like with the two balloon, asking people, what are the possibilities? I'm not interested in the right answer just yet. What are the possibilities? And getting them to brainstorm multiple hypotheses that might explain it. But both experience great joy. Human beings are naturally curious. And when something different happens than we expect, our evolutionary wiring causes us to wonder why and try to answer that. But actually, the younger children often are more willing to take risk and offer ideas, and very creative ideas that oftentimes are near the right answer. One of the most important attributes of being a teacher is that you're a learner. And that professional development side of teaching is often not supported. But teachers, using a book series like this, even without a funded program, people can pair up in twos and work on activities and swap their ideas. And teachers who are learners, that's projected in how you teach. The curiosity and the questions, and oftentimes the best professional development books are the books that challenge us to think differently and to create our own new questions. And so that's what I am interested in offering teachers interesting activities that will help them engage their students. But I'm even more interested in actually engaging the teacher and rethinking some of what they know about science, rethinking some of what they know about pedagogy. As a teacher, you get paid to learn. And so that's my hope for the books, is that they'll give people sort of a catalyst for teachers learning, as well as give them neat activities they can use with their kids.